Hi again, this will be our last video with a small robot, because we're ready to move on to the big ones. Today we're going to do something important. We're going to learn how to make completely new commands from scratch, or almost from scratch, so you can make your own commands for the competition. Today we're going to write a new command for the little XRP robot, and here is what it will be able to do. How did it work? Let's take a look. First, XRP has this infrared reflectance sensor in here. It has the right sensor and the left sensor. And what they do is they sense, is the surface under me more like dark or more like light in the infrared light. And this cheap carpet, link in the description, has two sides. The flat side is actually very, very light, very reflective in infrared spectrum, whereas the squishy side, the fluffy side of the carpet, is not. So we use the light side, the flat side of the carpet for this. On top of this carpet, we have put some Scotch blue tape. And even though it says blue, if you look at it in infrared spectrum, it will be more like black. It does not reflect infrared very well at all. And so the robot is able to sense, is my right reflectance sensor above the tape, but my left reflectance sensor not above the tape? Uh-oh, I have to turn right. So that's all there is to it. Sounds simple. Let's write the code to actually do this. So if you break it into steps, we need to actually do two steps. One is the robot needs to reach the blue line, like this. And after it reaches the blue line, the second command to follow the blue line and drive along. Okay, so let's go to GitHub and XRP3CMD, link in the description, is where we have the example code that we will be using for today. I need to open PyCharm so we can download this code into our PyCharm to play with. If you have something else, open it, as I do in here. You can just go and say close project. Close. Project is now closed. And now you'll have a button here. It will say get from VCS or it will say clone. Clone means download. Maybe you already have done this and you don't need to do anything, but in case you haven't, there will be a URL. So you just take the URL for this code example that we have and put into here, into the URL field of the form, and hit clone. The code is getting downloaded. The code is downloaded. XRP3CMD robot code. The only thing that you might have to do is you'll have to go here and you say click the lower right corner and pick the version of Python. We will be using Python 3.9. So I click, I say add local interpreter, and I'm going to be picking I'm going to be saying that I will need Python 3.9, and I'm going to call it Dutch Venv. Don't ask me why. You can call it anything you want. Hit OK. And after this is done, what I can do is I can go to this terminal window to install all of the things that I need to install for this to work. I click terminal button in here and I punch pip install -r requirements.txt so that anything that's needed is downloaded. What is requirements.txt? If you go to the project view and you click on requirements.txt, you will see that this is the list of all the things that are needed to be downloaded for this robot code to run. And let's take a look at the terminal again. Looks like everything is installed. So we should be able to run this robot code. If your robot has a camera, you can run robot with camera. If your robot does not have a camera, then you should be running robot without camera. And if you just want to do a simulation without a robot, you can just click without robot, and it will run without robot just fine. It will actually be using your laptop camera. So let's see if we can run this robot code without camera. I'm going to connect to my XRP Wi-Fi. I need to first turn it on. I'm turning the XRP on, but I'm not going to turn on the camera, just the robot itself. Now, if I look at the list of my Wi-Fi's in here, I should hopefully see the XRP network. It's coming up here. Connect. Connected. We are connected to my XRP. And if I run robot without camera, I should hopefully see the user interface for this robot code. It's taking some time the first time you do this because it's compiling or producing the bytecode, I should say. There we go. We have the robot started, and if I click on the autonomous command, it should start doing something. The wheels are turning. It's trying to drive, but I'm just holding it in my hands. If you open the smart dashboard, you will see that the X and the Y coordinates are updating. The robot is thinking that it's driving. Okay, we can now get it to work to follow lines. So if you go back to the source code of XRP3CMD, we need to go to robotcontainer.py. This is what most of the students actually need to change for first robotics competition. There are two functions in here. One, configure button bindings. To configure the buttons for your joystick, which button does what for teleoperated part of the competition. And for the autonomous part of the competition, we need to do something in this get autonomous command function, right? So let's do something. First of all, let's write a simple command that will make the robot drive to the line. Drive forward equals drive distance, and we specify inches equals 50, for example, just speed equals 0.35. Let's drive slowly so we don't miss the line. And we need to give it, what else do we need to give it? I'm gonna hover over this drive distance command so it shows us what else is needed here. We need the speed, we need the inches, and we need the drivetrain. Okay, drivetrain equals self.drivetrain. And let's just use this as our autonomous command. So get autonomous command function will return, or we can say auto 0 equals drive forward. This is our autonomous command. Return auto 0. Let's see if it works. I'm starting the code in robot without camera configuration. Start. The window is up, so I can switch my robot into autonomous, and it will run the autonomous command. Drive, 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 go to the line. Wait, why is it not stopping at the line? Why is it going past that line? Okay, I think I know why this is happening. So the command that we created is to drive forward by 50 inches. We forgot to say anything about stopping at the blue line. And how do we even make the robot stop at the blue line? Fortunately, if you go to the drivetrain subsystem, it has a function here. What is it called? The function is called isAboveTape. What this function does is it checks the right and left reflectance from the reflectance sensor. And if it looks dark, both on the left reflectance sensor and the right reflectance sensor, then this function returns true. Yes, I'm above tape. Looks like I'm above tape. So what we can do, if we go back to robot container and the autonomous command code, we can create another command to drive forward, but only until the robot is above tape. We can call it go to tape. So we can take the existing drive forward command and then modify it with a function called until. Drive forward until drivetrain is above tape. Now we should not be using parentheses here. We should not be calling this function in here yet, because here we're just setting up the autonomous command. This function should be called later, so we're going to get rid of the parentheses. And now we created another command, go to tape, which just takes the original drive forward command, but it will stop, it will only work until drivetrain reports that it is above tape. So let's make sure now that this go to tape command is going to be our autonomous command. Let's see if it works. I'm starting the robot code without camera. I'm going to the interface and I'm clicking autonomous. And the robot drove till it reached the point above the tape. Then the command stopped. Perfect. Great. So this until function appears to be very useful because it can stop your command exactly when you want it to stop. Okay, so now let's go back to our autonomous command function inside of robot container class. And let's forget for a moment about driving to the tape. Let's figure out how for the robot to actually follow the line, follow that tape. So I imagine we'll have to put together some kind of command. Follow equals follow object. No, not object. Follow line. Oh, great. Someone already wrote the follow line command. And we need to give it drivetrain equals self.drivetrain. Problem is, this follow line command is kind of here, but it is actually not written. I have put what is called a stop implementation, which is you can, if you go to the commands folder in here, you can kind of see that there is something called follow line, but the command is actually not fully written. To write a command, any kind of command in WPILib, you need to create a class, for example, follow line, and you can say that, yeah, that's a command. And then you need to define 4 functions. You need to write 4 functions. What to do when the command starts? What should the robot do when the robot is moving? It's called execute. Then we need to write a function what to do at the end when this command is done running. For example, drivetrain.stop is written in here. So we want the robot to stop driving when the command is finished. And another function to say, to determine are we finished running this command or not. What happened is I started writing this function some time ago, but I never finished it. Here is what it's currently doing inside of the execute function. It's getting the reflectance sensor, it's getting the left reflectance and the right reflectance. And you know how this reflectance works. If the robot is over something dark, the reflectance will be very small. So, for example, if the left reflectance sensor is above the tape, the dark tape, then maybe left reflectance will be 0.1, 0.2, 0.4, something dark, something small. But if the right reflectance sensor is above something light, like the carpet, then the reflectance will be very high, 0.9, 0.8, you know. Now, of course, if the sensor is malfunctioning, maybe it will give you a 0, or maybe it will give you, for example, 100% reflectance. This cannot be, this is not true. So what this code does is it checks, is my left reflectance like -1 or -10 or 0, or is it above 1, which is also not physically possible. If any of this is happening, then probably the sensor is not connected or it's broken. And it checks the right reflectance, the reflectance on the right sensor. Is it less than 0 or is it more than 1? You know, if any of them is invalid, then probably the sensor is broken or not connected. And what it does is it reports to the screen that we have an invalid reflectance sensor and declares that the command is finished. Self.finished equals true and doesn't do anything else. Return. Now, if both sensors are now above the bright carpet, then probably we are finished driving. So if they are both very high, more than 0.76, maybe 0.9, 0.95, over something bright, just the carpet, then we don't have the line anymore. And again, the command is finished. The robot should stop. Now, if robot is driving over the line, actually, but the left reflectance is 0.9, so the left sensor is not looking at the line anymore, but the right reflectance is still 0.4, so the right sensor is still above the line. Then we kind of need to write the code for the robot to turn right in here. And I have never done this. What I did is I have put a to-do here item. To-do, actually write the code for the robot to turn right or left. So let's think about, let's say, for example, left reflectance is 0.9 and right reflectance is 0.3. So the right sensor is above tape and the left sensor is not above tape. If this is happening, then the diff, which is left minus right, will be very positive, right? It will be minus 0.9 minus 0.3. That's a very big difference between the two sensors. So if left is not on the tape and right is on the tape, then we need to turn back right, back towards the right sensor. Let's write this in the code. If the diff, we can say if left is reporting much bigger difference than the right, if left is greater than right plus 0.15. Then we want the drivetrain to make a right turn. So we need to say drivetrain.drive with a small forward speed, for example 0.15, but with a right turn. Right turn is negative rotation speed. For example, minus 0.3, something small. Now, but what if the robot actually needs to turn left? Because its right sensor is above the tape, but the left sensor is above the tape, but right sensor is not above the tape. We can have another if statement. If right sensor is bright, which is much brighter than left, plus 0.15, much brighter than left, then we need to actually turn the robot left instead of right. So we'll make it move with a constant forward speed that's very small, slow move forward, and rotation speed of plus 0.3. So turn left if the left sensor is above the tape, but the right sensor is not above the tape. And finally, I guess we can say else, elif. And else, finally, if they are both dark, if the left sensor is dark and the right sensor is dark, then the robot is above the line and it should just move forward. Self.drivetrain drive with a forward speed of 0.35, drive a little faster, and with no rotation speed, 0 rotation. So that's what we need to do to make the robot turn towards the tape and keep staying above the tape. Let's see if it works. I'm going to put the robot directly on the tape, like this. And I'm going to start the code. Okay, this didn't quite work, because if we go back to robot container, we created the command to follow the line, but this autonomous command function is actually not using this. Instead, it's returning auto0, which is go to tape, and that's not even defined. So auto0 that we're going to be returning out of this function should be the follow command, the one which we just finished writing. Now we can start the code and see what robot does. I'm hitting the autonomous button, and the robot will start moving. it is able to turn back towards the tape, but sometimes it might be overshooting its turns. If we go back to the follow line command, we can notice that it's rotating with the speed of minus 0.3, which makes it overshoot when it's going back towards the line, overshoot towards the other side. So let's reduce the rotation speed so it doesn't overshoot. Instead of 0.3, make it 0.2, and try again. I'm stopping the old robot code, and I'm starting this robot code now, and putting the robot back on the line, switching it to autonomous. The robot is driving along the line, and it is not overshooting anymore. And if we look at the smart dashboard, we can notice that after the robot reached the end of the line, it has put a follow status message in here. Stop! No more line. Why is there no more line? Here we're printing out the reflectance sensor, 0.79 and 0.76. So both reflectance sensors show something bright, while line was black. If we go back to the code, we can see that this code was already here. If left reflectance sensor is more than 0.76 and the right reflectance sensor was more than 0.76, then we're supposed to put a string onto the smart dashboard to say stop, no more line, and print out the value of left and right reflectance sensor, and say that the command is finished. So everything is working. Now, if we go back to robot container, we have a command to follow the line. And we also have another command to go to tape. Can we maybe connect those two commands together? What if our autonomous command will be first go to tape, and then dot, and then follow? Then, in theory, the robot should be able to go to that tape and then follow it. If we use auto0 as the return value of this function. Let's see if it works. I'm going to stop this code and start the new code. And once everything shows up, switching to autonomous. Okay, it got to the line, and then it switched to the next command, follow the line. And it's following. Okay, Rubble, let's take a look at what we have done today. First, we were able to create a command for the robot to drive in a certain direction or to do something, but only until some sensor noticed something that we're above tape. And another command to follow the line. This command wasn't really written. The most important parts of it were missing. We went ahead and we wrote the most important logic of that command. If the right sensor is dark and the left sensor is bright, then turn right. And if the left sensor is dark and the right sensor is bright, then of course turn left, otherwise drive forward. This keeps the robot above the line, and we wrote this. We looked at how to write any kind of other command. You need to write 4 functions: initialize, what to do when the command starts; execute, what to do to actually run the command while the command is running; end. Here you write what to do when the command is finished. For example, stop the drivetrain. And finally, how to decide whether it's finished or not. If somebody said finished equals true, then we say, yeah, finished equals true. So you can write any other command this way for your robot. One last thing I forgot to mention. Let's make it a little bit more fun and measure how many seconds it actually takes for the robot to finish the whole line following. We have these 2 commands in here, start stopwatch and stop stopwatch. And the robot already has a stopwatch in it. So how about auto0 is start stopwatch and then go to tape, and then follow, and then stop stopwatch. Let's see what this will do. Starting the code and switching it to autonomous. Thank you for watching, and at this point you're actually ready to start working with big robots. And we will be posting a lot of videos about that. Please stay tuned.